Hello everyone. In this video, we're going to be solving a system of equations. We've probably done similar problems before, I can't remember, hopefully not the same one. We have x plus y plus z equals 5, and 2xy minus z squared is equal to 25. And we're going to be solving for what? X, y, and z. There are three variables, but we only have two equations. Is this a Diophantine system? No, not necessarily. Even though the solutions can be integers, we have no guarantee. We have to solve it. So we're going to be looking at it from a real number perspective, which means there can be, or can there be, infinitely many solutions, right? In the case of real numbers. So how do we approach a problem like this? Probably in more than one way, right? Let's go ahead and give it a try. So first step is I can just go ahead and isolate z from the first equation, can't I? So let's go ahead and isolate z because I want to plug it into the second equation. Hopefully that's going to give me something. I have no idea. I don't know what it's going to become. But we have x plus y plus z equals 5. So from here, if you isolate z, it's going to be 5 minus x minus y. Three terms, but that's okay. There's a formula for it. And we're going to plug it into the second equation, which is 2xy minus z squared. So we're going to replace z with 5 minus x minus y from here, as you know, square it, and the whole thing is equal to 25. I do see a 5 squared inside the parentheses. Do you see it? And I have 25 on the right-hand side, so they'll probably cancel out. Hopefully that'll be a good thing. Now let's go ahead and expand it. How do you expand something like this, right? Well, for a plus b plus c, we have a formula. It's a minus sign, but again, you can take it to be 5 plus negative x plus negative y. Hopefully that'll kind of help you simplify it. But anyways, here's how it goes. You square the 5, you square the x, you square the y. First, you take care of the squares, and then you do the two-way products. Don't forget, it's kind of like this a plus b plus c squared is a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ac. Did I say everything? I hope so. So it's going to look like this. You have to consider the fact that when you multiply these two things, it's going to give you negative 5x. You have to double it, so it's going to give you negative 10x, and then negative 10y. And finally, this will become plus 2xy. And that is going to equal 25. Beautiful. Two things that are beautiful here. This one is going to cancel out. It won't actually, never mind. But this one is going to cancel out. So let's go ahead and expand it. I thought it was going to, but it didn't work. Anyways, so let's go ahead and subtract it, negate it, simplify it, whatever. And then you'll get something nice, hopefully, right? We'll see. 2xy cancels out. Let's go ahead and get rid of that. 2xy minus 2xy is equal to 0. And since we have everything on the left-hand side, but with a minus sign, let's put everything on the right-hand side, okay? Let's negate, move everything. So it's going to be when these things move to the right-hand side, it's going to be like x squared plus y squared minus 10x minus 10y. And we're going to have to bring this negative 25 over. There's another 25, which is going to make it a 50. And the whole thing is equal to 0. Nice. Do you like it? I hope so. Now, this may not mean anything to you, but it's actually very meaningful. The only issue right now, which we had before too, is that we have two variables. We were able to eliminate the z. Yes, that's a good thing, but we ended up with a single equation. If you ever try to substitute again or something like that, don't try it because you're going to be going around in circles. There's no way you can get to an equation with a single variable. So this is a special type of equation, and again, we're looking for real solutions. That's why we have to approach this very carefully. But here's the thing, and we've used this idea in another problem on my other channel. Wait a minute, which channel are you talking about? I'm talking about a plus bi. Maybe that's where you came from, who knows, right? Because I always talk about SyberMath on that channel. But that's my channel that focuses on complex numbers. If you like complex numbers, go ahead and check it out. If you are new to complex numbers, or even if you don't like it, because you might end up liking it, right? There's a chance that you're going to fall in love with complex numbers. Now, on that channel, we just did a problem. I think, I can't remember the days because I usually record a couple videos back to back and then I just post them when the time comes, schedule them. So, but recently, maybe it was, let me think about it. Okay, that was on Saturday and today is Sunday, right? When you watch this video, it's going to be Sunday, at least. I'm recording this on Wednesday, but anyways. So yes. So yesterday, if you checked a plus bi or if you didn't, go ahead and check it out. you'll see a problem where we used this same idea, which is completing the square. You see how often these things come up? So if you're studying algebra or you need algebra for math competitions, Olympiads, whatever, this is something you should definitely know, okay? Quadratics, completing the square, conic sections, circles, parabolas, whatever. So here's what we're going to do. We're going to put the x squared and 10x together, and then y squared and the 10y together. And now we're thinking. And I probably need to move these two things because I do need some room here. Yep. So this is good. Now we need to add something to this to make it a perfect square. And that number can be found by cutting the 10 in half and squaring it. So you have to add 25 to make it a perfect square. And of course you have to do it twice, but that is adding 50. We already had a 50, so everything is balanced out. Great. I could also subtract 50, put a negative 50 there. When I add a 50, that will be 0. But guess what? Turns out to be the same thing, right? Same idea. Now let's go ahead and see this. What happens? Now this gives us two perfect squares. Hopefully you know what I'm talking about. This is x minus 5 squared, and try it. If you multiply x minus 5 by itself, you get that exactly, okay? And the same thing happens here from symmetry, and we get a beautiful equation. You know why it's beautiful? Because you're adding two squares and you're getting 0. And x and y are real numbers. Did I tell you that? Yes, I probably did. Because if x and y aren't real, then we should be on a plus bi, right? We're focusing on real numbers here. So, what are we going to do? Since no square can be negative, you can get 0 in two ways. If you're adding two numbers and you're getting 0, you're either adding a positive number and a negative number, or you're adding two zeros. You see, case by case. But here, if this number is positive, this needs to be negative. That's not possible. Or vice versa, right? It's impossible. So, what does that mean? It means that both of these numbers have to be 0 at the same time because x and y are real, x minus 5 and y minus 5 are real, so they both have to be 0. Ta-da! One equation gives us two variables. Is that cool? That's why I really like these kinds of problems. And x equals 5 and y equals 5 is the unique solution, the only solution to that equation. But wait a minute, what about z? Let's go back. X plus y plus z is equal to 5, which means z is 0. Are you serious? Well, here's the thing. If z is equal to 0 and x and y are both 5, then we run into a problem, don't we? Wait, no, z is not 0. Why did I say z is 0? Sorry about that. Okay, not good at arithmetic, I guess, huh? So, if x and y are both 5, then this becomes 10, so z needs to be negative 5, obviously, right? And if you check both equations, you'll know what I'm talking about. So when you multiply these, 5 times 5 is 25, double it, you're going to get 50. So z squared needs to be 25, which means z can be 5 or negative 5. But as you know, z cannot be 5 because 5 plus 5 plus 5 does not equal 5. I mean, you wish, right? That's wishful thinking. So this means z is equal to negative 5. And guess what? X and y are, but x, y, z are not all interchangeable. You cannot just switch them. Z is unique in this case. You probably know why, right? So that gives us the solution to the system, the unique solution to the system, which makes this problem really, really cool. And you can make many problems like this one by using some strategy. Maybe I'll talk about that one day, maybe Monday. So here's the second method. Let me rewrite the system. You probably forgot, right? Because I did, and I'm just kind of copying. 2xy minus z squared equals 24. And that's okay. You can take notes and I'll look at them whenever you need to. Now, what could be a second strategy, right? So maybe I can do this. Instead of isolating z, I can try to isolate x plus y, because if I isolate it and square both sides that way, I'll be getting 2xy. So that looks like a good thing, doesn't it? So let's do that from the first equation. Let's isolate x plus y. That gives us this. And let's go ahead and do the obvious, square both sides. And when we do, we get x squared plus y squared plus, I was going to write z squared, but no, 2xy equals 25 plus z squared minus 10z. Great. Now, what are we going to do? Well, we do have another equation. Let's just copy that, see if that gets us anywhere, right? 2xy minus z squared equals 25. Beautiful. So one thing you can do, and I think that's going to be super helpful, You don't have to do it that way, by the way. You can just replace 2xy with something because we have 2xy here. You see that? Or, even better, you see that 25? You can replace it with this. Take a look. It's going to be awesome. Now, from here I get x squared plus y squared. And now 2xy is just going to stay the same. And we're going to replace 25 with this. Make sense? 25 replaced with 2xy minus z squared. So like this. That replaces 25. Okay, like this. Plus z squared minus 10z. If this is confusing, you can go ahead and get rid of the box if you don't want it. I don't want it. Now, take a look at this. This is just awesome. Z squared cancels out, 2xy cancels out. Uh-oh. We ended up with something interesting, right? X squared plus y squared is negative 10z. You probably wasn't expecting this, were you? Now, did I say you wasn't? Okay, sorry about that. I meant you weren't. So, what am I going to do with this? Okay, here's what I can do. And this is actually really cool. Look, I know x squared plus y squared, and I do know that x plus y. X plus y is 5 minus z. Can you solve this system just treating z as a number? Yes, z is a variable, but just treat it as a constant and ignore the fact that it's a variable, right? So how would you solve a system like this? The answer is, I think, there's more than one way to do it, but you would probably square the second one, right? X plus y squared is going to be this. And then that gives you x squared plus y squared plus 2xy equals 25 plus z squared minus 10z, right? 10z. And then from here, you want to find 2xy. Our goal is to get xy in terms of z, makes sense? So replace x squared plus y squared with negative 10z. Uh-oh, these two cancel out. Nice. And then you end up with 2xy equals z squared plus 25, which you can write as xy equals z squared plus 25 divided by 2. You might be asking, like, what on earth is he doing, right? Where does that come from? How did you know that? Okay, there are good questions. But let me go ahead and bring down the x plus y, and I'm going to talk about an important French mathematician whose name is Francois Vietas. Did I say that right? French people. Okay, people who speak French. I hope so. But there are formulas that are called Vietas formulas. Vietas said that, is it Vieta or Vieta, something like that. He said that we can actually set up a quadratic equation whose solutions are these. What's the use? You'll see now. Let's suppose that this equation is written in a different variable, so we're not confused with x and y. Because what I'm about to do is, I'm going to use the sum of the variables here and the product here. You know what that means? It means when you look at the sum of the roots and the product of the roots, remember, in a quadratic formula, ax squared plus bx plus c equals 0. The sum is negative b over a. These are Vietas formulas, by the way, but I'm just using them in the opposite direction. And the product is c over a. This is what I used, but in the opposite direction, okay? Hopefully that makes sense. Now, we have a variable t, and t represents x and y, by the way, both, because this equation has two roots, and those roots are x and y, right? And then what I can do is, well, maybe multiply everything by 2 first, because that'll be better. And you can actually negate as well, because I don't like the minus sign. Actually, minus sign is okay, because b squared minus 4ac, that might work. 10 minus 2z, okay, fine, I'm not going to touch it. And this will become z squared plus 25. Now, we're going to look at the discriminant of this quadratic equation. Why? Because our teacher said so, right? So the delta is going to be negative b, which is this. Wait a minute, I'm talking about delta, I got confused. B squared minus 4ac. So b squared minus 4ac, right? All right, awesome. Now let's go ahead and simplify this. This is going to be cool. A lot of things we're talking about, right? This is 100 plus 4z squared minus 4dz, because 2ab thing, remember, minus 8z squared, because this is 8, minus 8 times 25, which is 200. Great. Let's simplify this. Negative 4z squared minus 4dz minus 100. And then, what can I do? I can divide, I can factor out a negative 4. Negative 4 times z squared plus 10z plus 25. This is a perfect square. Again, you see, they always come up, don't they? Now, what is so significant about delta? Right? Why did I look at delta? Now take a look. If you want real solutions for t, which is x and y, you do need the delta to be greater than or equal to 0. That's a must, right? But wait a minute, this is a perfect square, and no square can be negative. So no negative square can be positive. Does that make sense? With a minus sign. So this has to be 0. Another solution. Z plus 5 is 0, and as you know, this results in z equals negative 5. If you plug it in, you get x equals 5 and y equals 5, and this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out SyberMath, which is this channel, and aplusbi, and happy holidays, and bye-bye.